Hello everyone! In this video, we will present the work done in the Catholic University of America during the summer about creating Paraview readable files such as VTU and PVD files. To do this, we will need to use the software MATLAB. First of all, we will show a shape of a common VTU file using Acomex to open the VTU. To open this file in Paraview, the shape of the file needs to be exactly like is shown here. It is necessary to have a header that shows the type of your file, the number of points, and the number of cells between these points. In this case, the type is unstructured grid, and we will create one cell with 4 points. Then, in the point section, it is necessary to mention the coordinates of each point, x, y, and z axis. In the cell section, we need to show the connectivity, offsets, and types. In connectivity, we show the connectivity between the points in each cell. In this case, our cell starts the connectivity in 0, going to 1, 2, and 3. Each point receives one number starting from 0, 1, 2, and 3. If we have more cells, we will have a line of connectivity for each cell. In offsets, we have the cumulative points in each cell. In this case, we have one cell with 4 points. If we had 3 cells with 4 points each, we would have 3 numbers, 4, 8, 12, and so on. In type section, we need to type the number that represents the arrangement of the points in the cell. The link for a website with some of these numbers is in the description of this video. If we had 5 cells with the arrangement of number 9, we would type 9, 9, 9, 9, and 9. Since we have only one cell, we just type 9 once. Then, in point data section, we will type the number of the scalar of each point. It follows the criteria desired. We have 4 numbers that represent our 4 points. Finally, we can open this VTU file in Paraview, click in Apply, and see the quadrangle shape. We can also change the representation and the color. Our main objective is work with a large amount of data points varying with time. Because of that, we will need to use a MATLAB code to read all this data and create many VTU files, one for each time desired. These are the points data, and we will open this file in MATLAB. In MATLAB, we open the file that contains all points data, which means the coordinates of these points, and the connectivity in the cells. Then we scan the file using fscanf function so that we can save only what is needed. Then we now create the VTU files. In this case, we use a for command to read the files in the output folder that contain the scalar values for each point in each time step. We then open a VTU file for each for command and use the fprintf command to print all necessary data in each VTU file created. In this section, we write the connectivity arrangement of each cell. Since Paraview reads each node starting from 0, and MATLAB reads points starting from 1, we use vector k-1. If we do not follow this pattern, we will get wrong shapes in Paraview. Then, in this part, we use a for command to print the value of each point's scalar according to the files we opened previously. Once you run this MATLAB code, we can create all these VTU files. As an example, this is one VTU file shown in Paraview. If we desire to create animations with the V2 files created previously, we need to create a PVD file. Once again, we open the file that we want to create in MATLAB. We then print the necessary headers and information in the PVD file using fprintf command. Then, we open the file that we want to create and use a for command to print the name of all V2 files created previously and each timestamp desired. The MATLAB code for creating PVD files and the V2 files need to be in the same folder. Finally, we can run and create the PVD file. After creating the PVD file, we can open this file in Paraview. Once it appears in Pipeline Browser window, we click in Apply in Properties. Then, we change the color to the name of the scalar and then click in Play in the upper bar. If we desire to save it as AVI, we go to File and click in Save Animation. We choose the name and then wait for Paraview to save the animation. And this is our file as AVI. Also, it is important to highlight that we can change the color of the shape and show it as a mesh. We go to Representation and change it to Surface with Edges to show the mesh. Then, to change the color, we can select the scalar color and then click in Edit. We can rescale to the adequate value and then run to see the difference in the color and in the movement. As we can see, the wave after some time steps is meaningless, that's why the color doesn't change anymore.